Oman, please go ahead.
Good morning, everyone. I'm glad to be here to make a brief presentation about my paper entitled Optimal Application, Timing, and Cost Effectiveness of Crack Sealing in Asphalt Concrete Overlays in Louisiana. So, generally, surface cracking is a major failure mechanism in asphalt pavements. And the reason for that is that surface cracking allows water infiltration into the pavement, which accelerates the pavement deterioration, resulting in stripping, base failure, and potholes. And that's why crack sealing is commonly used in Louisiana to treat and control these surface cracks. So as you can see here, this is a picture of crack sealing, and this picture shows a common failure in our roadways, which is a pothole. So the benefits of crack sealing in terms of the extension in pavement service life has been well researched and documented in previous studies. So there have been several studies that evaluated the performance of crack sealing to determine how long does it live. And most of the studies found that the crack sealing extends the pavement service life between about 2 and 4 or maybe 5 years. However, the main challenge with crack sealing, specifically in the southern United States, is that the cost effectiveness of this treatment is not well established. And another major problem is that the optimal timing of crack sealing in terms of the pre-treatment pavement condition also is not well established. So that's why crack sealing is rarely incorporated into the pavement management system. So in Louisiana, for example, crack sealing is applied on roadways without going back to the PMS. It's just based on visual inspection, which is subjective to a great extent. So this takes us to the objectives of this paper. So our objectives were to evaluate the cost effectiveness and optimal timing of crack sealing on asphalt overlays in Louisiana. So in specific, we evaluated the cost effectiveness of this treatment. We also evaluated its optimal timing. So we were trying to provide guidance for state agencies when to apply, like a quantitative procedure of when to apply the crack sealing to achieve the optimal benefits of this treatment. We also developed a regression model to predict the cost effectiveness of this treatment to help state agencies to determine the cost effectiveness of this treatment without any complex calculations. And finally, we developed a decision-making tool, and again to help the state agencies to select their optimum maintenance treatment and the optimal timing of this treatment. So I'll go briefly over each of these objectives to show how they were achieved. So this flow chart shows the methodologies that we followed in our study to achieve our objectives. So first, we started with the data collection. So in this study, we collected crack sealing projects in Louisiana. And we collected also asphalt overlay projects in Louisiana. And the reason that we collected the asphalt overlay projects because the crack sealing projects in Louisiana, or crack sealing in general, is applied over asphalt overlay projects. So to determine the cost effectiveness of this treatment, we need to first evaluate the effectiveness or the cost effectiveness of the asphalt overlay projects. That's why they were collected in this study. And we also collected ship seal projects. And in this study, the ship seal projects were only used as a baseline for comparison. So for all of the collected projects, we collected the treatment costs and we determined the treatment benefits. And then for every project of these projects, we use the EAC, the equivalent annual cost, and the life cycle cost analysis in terms of the benefit cost ratio, as well as the cost effectiveness. So we use these three different economic measures to determine the optimal timing of crack sealing application. After that, we considered a separate case study, and for this case study, we conducted further life cycle cost analysis in the terms of net present value to determine the optimal long-term strategy and the optimal timing of this strategy. At the end, we compiled and incorporated all of these results into an enhanced decision-making tool. And again, I will go quickly over this tool to show how it works. So first, the first step in this in our methodology was to identify the candidate sites. So what we used, we use a video crack surveys to locate the crack seal sections. So for example, in these two pictures, they show a road before and after crack sealing. So as you can see in these two pictures, the upper picture shows the road before applying the crack sealing, and then the second road the second picture shows the road after applying crack sealing. So using these video crack surveys in the database of Louisiana Department of Transportation, we were able to determine the exact location and the exact date of the crack sealing. So before going into depth into the data collection, I just want to give a brief overview over the random cracking index, which is the key input used or the key variable used in this study. So the random cracking index, it's available for every state highway in Louisiana every 2 years, starting from 1995. And it's collected and reported every 1/10 of a log mile, and it includes all the random cracks on the surface, including the thermal transverse, the reflective transverse, longitudinal, block, cement-treated reflective cracks. And generally, this number, it ranges between 0 and 100, with 100 is a perfect condition. So if you have a random cracking index of 100, so this means that you have any cracks on your surface. So in this study, we collected 190 log miles included in 19 crack sealing projects, and for every log mile, we collected the RCI negative, the unit costs, and the increase in the pavement service life. So we collected this for every of these log miles. So RCI negative, this is very important parameter in our study, and again, this is a pre-treatment pavement condition. So if you applied crack sealing, it's well recognized that the pre-treatment pavement condition significantly affects the performance of the crack sealing. That's why we were looking into the pavement condition before applying the crack sealing, which is the RC negative. And also the unit cost, it's easy to get the unit cost. And we determine the delta PSL, which is the extension in the pavement service life after the crack sealing is applied. So we collected this data for 190 log miles included in 19 projects for the crack sealing. And we collected the same data for 227 log miles in 21 projects, ship seal projects. And again, we collected the same data for 141 log miles included in 141 projects of asphalt overlay. So after that, we started with our analysis. We calculated the equivalent annual cost as the unit cost dollar per lane mile over the delta PSL. And again, when we calculated the equivalent annual cost, we calculated this for every treatment, for every log mile. So we did this for every log mile, for every treatment. And after that, we categorized the calculated AAC based on the pre-treatment pavement condition and based on the treatment. And at the end, we calculated the average for each group. So to say it in a more simple way, let's look at this table. So this value, for example, this value shows the average equivalent annual cost for all the log miles which were crack sealed that had RCI negative between 77 and 80. So this is what we simply did. So looking at this table first, the first thing that we can say is that comparing the asphalt overlay with the crack sealing and the ship seal, the EAC values were much higher for the AC overlay when compared to the crack sealing and ship seal. And again, this is expected, and this shows that crack sealing and ship seal are much more cost effective than the AC overlay, which shows the importance of applying maintenance treatments other than just applying the rehabilitation treatments. And then looking at the crack ceiling, we can see that the lowest AEC, which is the most cost-effective scenario, was when the RCI group was between 81 and 84 and 85 and 89. So this simply suggests that from the EEC perspective, the optimal timing to apply crack sealing is when the RCI, the random cracking index of the asphalt overlay, drops from 100 to any value between 81 and 89. So we did the same analysis, but we used another economic measure, which is the benefit cost ratio. And this equation shows the calculations for the benefit cost ratio. And this figure shows the average benefit cost ratio for the different pre-treatment groups. And as we can see, for crack sealing, the highest BC was achieved for the RCI groups, again, for between 81, 84 and 85, 89, which is consistent with the previous economic measure. And again, this suggests that the optimal timing to apply crack sealing is when the pre-treatment condition of the overlay drops from 100 to any value between 81 and 89. And again, preferably in this case, it's between 81 and 84, since it has higher benefit cost ratio. After that, we repeated the same analysis, but with using another economic measure, which is called the cost effectiveness. So first, I will give a quick overview about this economic measure. So if we look at this performance curve, it shows the pavement age against the random cracking index. So this is the performance curve before applying the crack sealing of the original pavement. And then at this time, we applied the crack sealing, and that's why the RCI went upwards. And after that, this is the pavement performance curve for the crack sealing. So simply the cost effectiveness, it is the treatment net benefits divided by the unit cost of the treatment. So the treatment net benefit, it is the total area or the net area under the treatment, the crack sealing, which in this figure will be area 2, which is this area minus area 1. So this is how we calculated the cost effectiveness. So again, we calculated the cost effectiveness and we calculated the average value and we plotted these values against the pre-treatment groups. And we found that higher cost effectiveness values, which is a more cost effective scenario, was obtained for these two groups for crack sealing. So based on the three economic measures that we use in this study, the EAC, the benefit cost ratio, and the cost effectiveness percentage, we concluded that crack sealing should be applied when the random cracking index before the treatment or the pre-treatment pavement condition is between 81 and 89, and preferably between 81 and 85. We also recommended that crack sealing should be avoided on any pavements having random cracking index greater than 90, because at this point, the original pavement still has its service life, so applying any treatment would be useless. So these are our final recommendations regarding the optimal timing of crack sealing based on the pre-treatment pavement conditions. So after that, we tried to develop a model to help state agencies to determine the cost effectiveness without the need for any calculations. So we developed a model to predict the treatment net benefits that we just discussed. And again, once you have the treatment net benefits, so you can divide it simply by the unit cost of the treatment to determine the cost effectiveness. And this equation shows the final models that we developed. So simply you will determine the treatment net benefits knowing the random cracking index before the treatment, before applying the crack sealing, and you can easily get this from the PMS database. And then A is the pavement age, which is the age of the original pavement. And again, you can get this from the historical records. And then this is the ADT, which is a traffic level, which again, you can easily get from the PMS. And then this is delta PSL, which is the extension in the pavement service life after applying crack sealing. And the problem with this equation would be also only in this term, because when you apply crack sealing, this value is unknown. So that's why we have a previous study that we developed. In that previous study, we developed a model that could be used to predict the delta PSL. So that's why we recommend that when you use this equation, you need to use the other equations that we developed in our previous study. That's why what we did to compile all of these results, we developed an enhanced decision-making tool that includes all of these equations. So you just need to insert the project conditions or your inputs, and you will get everything like the delta PSL and the treatment net benefits for everything. And I will discuss this tool in a few minutes. So this is the equation that we used to predict the treatment net benefit. And again, this is the predicted against the actual treatment net benefit using the fitting data and the testing data. So we use about 80% of the points for fitting and 20% for testing. And again, based on the R-square, we can say that this model is generally acceptable. So now I will go over the enhanced decision-making tools that we developed. So again, before going into this tool, I want to emphasize that this tool was based on the results not only of this paper. So what we actually did, we have like 6 or 7 articles related to the maintenance treatments in Louisiana. So in this model, it includes or compiles the results of all of these papers, including this paper that I'm just discussing. So I will discuss the model that includes everything. So the objective of the tool is to select the best maintenance treatment, whether it's do nothing, crack sealing, chip seal, or microsurfacing, to be applied to an existing asphalt overlay based on the specific road conditions. So let's say that you have an asphalt overlay, and at some point you want to know which treatments that you need to apply, whether it's do nothing, crack sealing, chip seal, or microsurfacing. So the tool would help you with this task. And again, the factors or the criteria that we consider in this tool when we are for the selection, first, it's the surface distresses, like the rutting, the random cracking, the roughness, and distress. Generally, is the surface distresses. And the second parameter is, or criteria, is a subsurface moisture damage, because previous studies have indicated that when these treatments are applied over the asphalt overlay, sometimes they trap moisture and they lead to stripping and moisture damage. That's why in our selection criteria, we consider this point. And the last criteria is the cost effectiveness of this treatment. So it's very important to note that when we are selecting the treatment for a specific road, it's important to consider these 3 factors. Because let's say that, for example, crack sealing is more cost effective for a specific road. Let's say that crack sealing is more cost effective than chip seal. But at the same time, the crack sealing might not address the surface distresses that are existent on your pavement. That's why you cannot just look at the cost effectiveness and say, okay, crack sealing is more cost effective than chip seal or microsurfacing, so I will apply crack sealing. That's why you need to consider all the 3 criteria. And I will show you how that these criteria are considered in our model.
A moment, I just want to ask you if you could wrap this up fairly quickly. We're at getting to the time for this presentation, so we have time for you for your next one, and we have the 4th presentation too.
Okay. So the second objective is to determine the optimal timing of the treatment, and again, the tool could do this, and I will show you also how it's done with the tool. So once you start the tool starts with a master sheet with 7 steps that you need to accomplish in this order. So when you press on the first button, it will take you to the instructions. For the second button, it will take you to enter the general data applicable to the site. So year A is the year at which the overlay was applied, year B is the base year, and year C is the year at which the treatment will be applied. And again, these are the necessary inputs that you need to input. And again, we provide minimum and maximum values. And after that, you will need to enter the maintenance treatment unit costs. And again, we provide like typical values to aid the user. And after that, step 4 will be enter the existing asphalt overlay data. And again, all of this data, if you look at this data, you can easily get this data from the PMS. And then step 5 is the first step, is the first page of the output. So it simply tell you based on your road distresses which treatment is recommended. And then for step 6, it tells you whether, and again, it's based on your climatic condition, whether there will be stripping or not. And finally, the last step is going to the performance and the cost benefit results. So it gives you for every treatment, the extensions, pavement service life, the EAC, the benefit cost ratio, and the cost effectiveness that we just discussed. So again, based on sheets 4, 5, and 6, you can determine the optimal treatment for your road. So the final conclusion is that crack sealing should be avoided on asphalt overlays with pre-treatment condition greater than 90, and it's the best optimal timing to apply this treatment is when the pre-treatment condition drops from 100 to 81 to 89. And finally, an enhanced decision-making tool was developed to help state agencies select the optimal treatment and the timing of this treatment based on the road conditions. Thank you.
Great, thank you very much. We do have time for a question, if anyone has a question for Dr. Mosa. All right, not hearing anything. We'll move to our next presentation, and just to update you, we do have our 4th presentation for this session too. So we have 2 more presentations in this session. Our next presentation is